All right, today we're looking at the geometry that is needed for complex numbers and beyond. Geometry and circuit geometry is no longer in the new syllabus for stage 6 for used to be in advanced geometry, and circuit geometry used to be in extension 1 and extension 2, but they cut out completely now. But you need it for some parts of complex and some parts of vectors. So these are the 6 that I have on the board here. The first one is the exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. That one equals that one plus that one. Tangents drawn from external point to a circle are equal. The angle between the tangent and radius through the point of contact is the right angle, so that's 90 degrees. The angle at the center of the circle is twice that as circumference stand on the same arc, so that one at the center is twice that as circumference. And opposite angles of a cyclic quadrilaterals add up to 180 degrees, or they are supplementary, or they add up to pi in terms of radians. This is called a cyclic quadrilateral, by the way, in the old course, as is in circuit geometry that you learn in year 10. And the last one you don't learn in year 10, you don't learn anywhere, but it's common sense, basically. But the problem with common sense is not bloody common. The shortest and the longest distance from an external point to a circle. The shortest distance is actually the one that goes through the center, is on the line that goes through the center. And so is the longest one. In this case, the center is here. The shortest distance is AD. Longer distance, rather, is AD. And the shortest distance is AB. And AB being AC minus BC, which is the radius. And AD being BD, which is diameter plus, is AC, rather, plus CD, which is the radius, plus the AC distance. So those are the 6 properties that you need to know. How do you use that in complex numbers? Well, here is I've summarized it for you for the different cases. The exterior angle of a triangle is used in the arc locus. The second one is also used in maximum minimum argument. The fourth one is in the arc as well. And so it's the 5th one. And the last one is in maximum minimum modulus. And there's actually one 7th one that comes to my mind. The 7th one is actually this. If you have a chord and you have a center of that circle, the center to the middle of that chord will be 90 degrees to that chord. That's the other one that you need for the arc one, you know, Z minus Z2 equals theta business. So that's your thing over there, right? And so these are all the properties you need for circuit geometry and geometry that you need in complex numbers and vectors as well. And that's where I'm going to stop right there.